Satoshi Terremoto's book, Earth, Sky, and Stone, asks a direct question. What exactly are we looking at when examining the planet's most massive ancient structures? For most of the human story, existence was defined by immediate survival. Small, nomadic groups followed the rhythm of the seasons and the movement of herds, leaving behind nothing but scattered tools and weathered bone. Conventional history assumes that civilization and monumental construction are recent developments, appearing only with the rise of formal cities and the establishment of organized kingship. However, evidence of a psychological shift appears much earlier in the record, buried beneath the soil of the Near East and submerged along coastlines lost to the rising seas of the Ice Age. This evidence suggests a transition that standard timelines struggle to explain. That blind spot forces us to ask a difficult question. Did precision stone engineering slowly develop out of that icy wreckage, or did it survive the cataclysm intact, passed down from an older, forgotten epoch? To find the answer, we have to look past arbitrary carbon dating. We must examine the physical life cycle of the oldest stones themselves, stripping away the timeline to look purely at the mechanics of the engineering. The builders frequently bypassed accessible, soft limestone in favor of incredibly dense igneous rocks. They chose to work with materials like diorite, granite, and basalt. Historically, the tools assigned to this era were made of copper and early bronze. When struck against stone of this density, those soft metals simply deform and dull. Yet the archaeological record contains perfectly symmetrical, flat surfaces and deep cylindrical core-drilled holes. Achieving these results requires controlled, high-speed rotary friction and hard abrasives. This level of material mastery suggests a highly refined toolset and an accumulated understanding of material science, an infrastructure of knowledge that remains missing from the current historical record. True physical mastery is revealed in how these extremely hard materials were subsequently shaped. At Sacsayhuamán in the Andes, we find complex polygonal walls where massive, multi-angled blocks fit together with microscopic precision. There is no mortar here, only heavy, irregular rock bearing perfectly against rock. A few hundred miles away at Puma Punku, builders took this geometric mastery even further. They executed sharp internal right angles and perfectly straight recesses directly into solid rock. Andesite and granite are incredibly dense, igneous materials. Shaping them to this degree requires tools significantly harder than the stone itself, used with a level of control that mirrors the output of modern mechanical cutting. The correspondence between these masonry solutions across entirely disconnected continents suggests a shared set of engineering principles. On the slopes of Rano Raraku, an entire extraction industry sits frozen in place. Dozens of massive molai lie partially carved into the bedrock, left exactly where they were, as if the workforce simply dropped their tools and vanished. In Egypt, the raw mass being moved is almost incomprehensible. The unfinished obelisk remains locked in its granite trench, a 1,200-ton block that would require modern heavy-lift logistics just to move. This method of high-tonnage earth removal is not confined to a single continent. Across the Mediterranean in the Levant, identical extraction methods were applied to solid limestone. The foundational blocks they pulled from the quarries at Baalbek weigh up to 1,000 tons each. These masses exceed the capacity of most modern industrial machinery. Deep inside the Great Pyramid's King's Chamber, builders assembled massive blocks of rose granite to create perfectly flat, unweathered surfaces. They surfaced and aligned these stones with millimeter tolerances, working in what would have been profound darkness. Nearby, the Valley Temple of Khafre houses an array of massive monolithic granite pillars. The blocks are shaped with stark, sheer faces and fitted together with millimeter precision, showing a high level of proficiency in lifting and orienting heavy, hard stone. This shared obsession with the hardest known materials suggests a distinct engineering standard. The physical reality of the Giza Plateau contradicts this story of gradual growth. These monuments reflect a level of precision that exceeds the expected capabilities of an emerging society. The Great Pyramid relies on exacting tolerances. Its internal chambers utilize massive load-bearing elements, engineered to distribute millions of tons of weight with total stability. The evidence points to these structures being the final, fully realized legacy of a forgotten era. These stones stand as the physical remnants of a mature, systematic engineering discipline, a technology that arrived in the record already fully realized. This specific engineering language appears globally, manifesting in environments far removed from the deserts of Egypt or the plains of Mesopotamia. To understand the broader purpose behind this global stoneworking effort, we have to examine the oldest known monumental site on Earth, located in Anatolia. Göbekli Tepe is a clear architectural anomaly. Its massive circular enclosures and intricately arranged T-shaped pillars were erected thousands of years before the accepted invention of agriculture. These imposing stones act as physical hard drives. They lock in precise astronomical alignments and encode a rich symbolic language that tracks the deep time cycles of the night sky. Most surprisingly, the builders eventually buried the entire complex under thousands of tons of dirt. They deliberately concealed their work, attempting to protect an accumulated library of knowledge from an impending environmental collapse. Nearby, at Çatalhöyük, communal survival and ritual memory physically merged, resulting in dense, tightly clustered living spaces. These Anatolian structures functioned as early analog storage. They were intentionally engineered to outlast generational instability and maintain societal order through periods of chaos. This monumental response to the shifting climate was not contained to a single region. Evidence suggests it happened across multiple, independent locations near the end of the Ice Age. In the Fertile Crescent, the ruins of Jericho reveal increasingly permanent communal construction, complete with massive protective infrastructure. Deeply disconnected locations exhibit similar organized settlement geometries and massive stone usage, such as the scattered ruins at Gunung Padang. This presents a specific engineering problem. Quarrying, transporting, and precisely carving blocks of this size with only late Pleistocene technology is exceptionally difficult. The appearance of similar structures across the globe points to a shared psychological response to catastrophe, rather than a single lost global empire dispersing its knowledge. The exact origins, capabilities, and precise timelines of these builders remain subjects of active debate among modern researchers. The traditional academic view emphasizes a gradual environmental adaptation, while newer theories suggest these cultural traditions extend much deeper into the pre-cataclysmic past. We are left to determine exactly what environmental and celestial knowledge successfully survived these disruptions to influence the later periods of recorded history. Across multiple continents, disparate societies separated by geography and language invested in monumental structures built to outlast their creators. The heavy masonry and a recurring narratives of catastrophe both reflect a society recognizing the threat of cyclical disruption and preparing to survive it. If a message is intended to survive a localized disaster, it requires a medium more durable than Earth. The most enduring reference point available to early societies was the predictable, repeating motion of the cosmos. This celestial clockwork was embedded directly into the architecture. At Newgrange in Ireland, the entrance and a specialized roof box were positioned to channel the winter solstice sunrise down a long stone corridor, illuminating the inner chamber briefly each year. Other cultures constructed vast, horizon-based solar observatories. These 13 towers at Chunquillo in Peru act as a rigid calendar across the desert range, tracking the sun's shifting position to mark the progression of the seasons with absolute accuracy. These monuments functioned as active temporal frameworks. They allowed societies to lock their activities into larger cyclical timelines, providing a way to monitor the passage of time across generations. Deep in the Egyptian Sahara, the stone circles of Nabta Playa prove this instinct existed long before organized agriculture. Nomadic cattle herders arranged small megaliths to track the summer solstice and local star systems thousands of years before the rise of the pharaohs. Tracking the sky provided a stable external reference. By mirroring the movement of the stars, early societies built a framework to organize their own survival against the fleeting nature of time. This drive extended far across the Atlantic. In the arid sweep of the American Southwest, the Puebloan builders of Chaco Canyon constructed masonry complexes that echo the curve of the horizon. The canyon's major structures adhere to strict cardinal orientations. Walls and windows are placed to capture specific solar and lunar events, embedding celestial geometry into the desert floor. To the east, the Mississippi culture raised the platform mounds of Cahokia. These earthen monuments served as vertical extensions of the landscape, structuring movement and ceremony around the movement of the sun. Further north, the Hopewell earthworks cover miles of terrain. Enormous circles, squares, and octagons are aligned to the complex 18.6-year cycle of the lunar standstill, executed with a high degree of spatial precision. Curious, deliberate, cultures separated by thousands of miles and massive oceans independently arrived at the same solution. This earthly precision was synchronized to celestial mechanics. The builders anchored their structures to the movements of the sky. Circular megalithic monuments function as massive cosmic calendars. They track solar and lunar cycles, regulating the order of life through predictable celestial events. Ancient alignments map deep time cycles, celestial patterns that play out over centuries. They require sustained observation and meticulous record-keeping across generations. This fusion of stone and cosmic mechanics reveals a society anchored to the heavens. They tracked the sky with a degree of accuracy that suggests they were watching for something significant within its predictable rhythms. If these cultures watched the sky with such precision, we have to ask what threat they were monitoring. The record suggests they were watching a cycle of upheaval. The Younger Dryas was an era of violent, abrupt environmental instability that shattered the end of the last ice age. This map illustrates the world 12,900 years ago. Continental ice sheets dominated the northern hemisphere, supporting stable climates and expanding populations. Then, the cataclysm hit. Plausible fragmentation impacts, marked in red, triggered immediate disruption to global ice sheets. The secondary effects were immediate: megafloods, widespread firestorms, and extinctions. Human cultural continuity was abruptly severed as ecosystems collapsed. This chart captures the severity of that climatic whiplash. Global temperatures plummeted at the 12,900-year mark, leading to a millennium of instability before a violent spike back to warming. The Younger Dryas was a violent rupture. It forced humanity into a severe population bottleneck, turning a thriving expansion into a desperate fight for survival. The trauma of this cataclysm is physically recorded in the soil, carved into the landscape by the same floodwaters that reshaped the continents. Specific archaeological excavation pits reveal a distinct dark sediment layer. This marker provides physical proof of sudden, violent environmental shock. These soil markers represent absolute boundaries. Below them, we find the evidence of previous human settlements. Above them, that continuity is gone. This map shows the altered world that emerged. Retreated ice sheets and rising sea levels flooded coastal regions, forcing surviving populations to migrate and adapt to a new geography. The sophisticated knowledge required for the greatest megaliths may predate this climatic rupture. The engineering we admire may be a legacy of the world that was lost. Human history is a cycle of stability and sudden collapse. Our progress is marked by these transitions, moments where we are forced to migrate, adapt, and eventually rebuild. After the world shattered, the geological record suggests the ancient surface was periodically subjected to severe, rapid environmental resets, where stable landscapes were swept away by abrupt climatic shifts. Many ancient societies responded to this recurring instability by moving their populations and their knowledge systems downward into the bedrock itself. The Derinkuyu subterranean system in Anatolia demonstrates the scale of this effort. Extending 18 levels deep with integrated ventilation and storage, it represents a highly organized preparation for long-term survival. These massive underground networks reveal a deliberate survival strategy, suggesting early human societies were capable of sophisticated, long-range planning in response to planetary cycles. Thousands of miles away, the Longyu Caves in China provide evidence of a similar investment in subterranean space. Carving these uniform, massive chambers from solid rock required enormous labor, precise material extraction, and a high level of logistical coordination. The extreme architectural precision and uniform layout of these chambers suggest a role that required specific spatial and environmental control. These environments were designed for specialized interaction, utilizing the properties of the stone itself to achieve a specific internal function. To truly understand that function, we have to analyze the physical precision engineered into these isolated, dark spaces. In Egypt, we find subterranean spaces engineered for extreme material precision and a total isolation from the external atmosphere. The Serapeum of Saqqara contains massive black granite boxes carved with a level of symmetry and surface flatness, challenging the limits of known ancient tools. At the Osireion at Abydos, we see another layer of complexity. Here, massive, perfectly fitted stonework was integrated with persistent flowing water systems. Building within a saturated environment requires an advanced understanding of structural stability, ensuring the complex survived millennia of immersion. This emphasis on geometry continues at Abu Ghurab, where the exact layout and orientation of the stone indicate that spatial experience was carefully regulated. This extreme architectural precision established a controlled, unvarying baseline environment, permanently separated from the instability of the surface world. These isolated stone baselines were engineered to interact with the behavior of sound and vibration. The megalithic interior of Newgrange in Ireland was designed to trap and sustain specific frequencies, using the density of stone to shape the auditory environment. The Hall Seflieni hypogeum in Malta serves as a prime example of resonance architecture. Its curved ceilings and wall niches were carved to actively reflect and sustain acoustic waves. By manipulating the bedrock, the builders could catch and amplify specific vocal frequencies within the chamber. Acoustic analysis shows that resonance near 110 Hz can regulate breathing and synchronize brainwave activity, inducing states of high cognitive focus. These ancient builders utilized acoustic technology to engineer the psychological state of the participants, turning architecture into a tool for mental synchronization. This focus on sound provided a form of durability that physical records lack. Rituals reinforce memory through biological repetition and shared experience. The underground galleries of Chavín de Huántar in Peru used water channels and conch shells to create immersive sensory environments for ritual participants. Modern historical frameworks struggle to explain why these perfectly aligned, precision-engineered structures appeared so abruptly across distant regions. To find an answer, we have to turn back and examine what the ancient builders themselves recorded about their origins. Beyond the physical evidence of stone, ancient cultures recorded specific testimonies that explain how their knowledge systems began. This is the Sumerian king list, an administrative clay prism from ancient Mesopotamia, documenting lineages of kings and immense timespans before a great flood. Down these timelines, texts describe the Apkallu and Anunnaki, semi-divine intermediaries who taught early humanity mathematics, astronomy, and architecture. We see these knowledge bringers depicted throughout ancient art, like this winged Mesopotamian deity. They are consistently associated with celestial origins, carrying symbols of authority and instruction. These texts function as formal records. They present a clear claim that sudden leaps in human capability resulted from an intervention by an external source of advanced knowledge. This identical narrative structure repeats across entirely different geographic boundaries and cultural traditions. In the biblical tradition, Genesis 6 offers a brief, mysterious account. It describes the intersection of humanity with the Nephilim, forces operating outside of normal human experience, shortly before a massive global deluge. The Ethiopian Book of Enoch expands on this, detailing the arrival of beings known as the Watchers. The text claims these figures transmitted forbidden celestial knowledge, the secrets of metallurgy, and the blueprints for structuring society. From accounts of Quetzalcoatl in Mesoamerica to Viracocha in the Andes, the motif remains consistent. Figures associated with the sky arrive during periods of instability, bring sudden advanced knowledge, and then withdraw. The persistence of this specific sequence forces us to choose. Either these overlapping traditions are a shared psychological response to change, or they are the fragmented memories of a literal historical transfer of knowledge. When we look at ancient ruins, it is easy to see them as single moments frozen in time, original creations standing exactly as their architects intended over it. Later rulers frequently restored, repurposed, and claimed ownership of monuments that were already ancient when they arrived. Look at the Giza Plateau. The clean, recognizable profile of the pyramids often distracts from what lies at their feet: heavily weathered, coarse rectangular blocks that point to older, heavily eroded foundations repurposed by later dynasties. We see the same pattern across the globe. In Mesoamerica, the massive Pyramid of the Sun at Teotihuacan does not represent a single origin point. It was constructed in successive, multi-generational layers, expanding outward and upward over earlier structures. High in the Andes, the physical layering is even more stark. At sites like Cusco and Sacsayhuamán, distinctly older, highly precise megalithic foundations sit directly beneath later, far cruder construction. The later builders utilized the site, but they did not replicate the puzzle-like precision of the massive polygonal stones below. These physical intersections of different architectural eras suggest that the historical timelines we accept today might only be reading the surface layer of a much older, more complex sequence of human civilization. Our ability to read that deep sequence is heavily filtered by what actually manages to survive. Archaeologists call this preservation bias. Societies that built their homes, ships, and records out of wood, earth, and organic materials eventually vanish completely. This leaves a disproportionate emphasis in the historical record on the cultures that worked in stone. Even then, what we see is only a fraction of what exists. Stratified layers of soil bury ancient pits and foundations deep underground. Unexcavated terrain, submerged coastal shelves, and government-restricted locations guarantee that modern archaeology operates with a highly fragmented dataset. The megalithic stone endures, but the human societies that shaped it are exceptionally fragile. When a civilization collapses, whether from environmental stress or internal pressure, the vast majority of its accumulated scientific and cultural knowledge disappears with the people. Often, only the silent stones remain to indicate they were there at all. As we trace these fragmented stones further back in time, we eventually reach the edge of accepted archaeology, gray areas where our ability to confidently interpret the physical record begins to fail. Consider the thousands of hardstone vessels recovered from subterranean galleries beneath Saqqara. Carved from unforgiving materials like diorite and granite, they exhibit near-perfect internal symmetry and paper-thin walls, pushing the boundaries of what is typically attributed to early dynastic manufacturing capabilities. That tension between physical evidence and assumed capability expands when we look at massive earth formations that blur the line between natural geology and deliberate architecture. Nowhere is this more debated than the submerged Yonaguni Monument. Some researchers view its sharp right angles and stepped terraces as clear remnants of ancient engineering, but prevailing geology argues otherwise. Tectonic uplift and sedimentary fracturing can accidentally mimic human staircases with astonishing regularity. Terrestrial counterparts like the Sage Wall in Vermont and the Texas Rock Wall provoke the exact same debates. They exhibit combinations of scale and alignment that resist easy categorization. These formations sit precisely on the edge of human interpretation. They lack definitive proof of advanced design, yet they are difficult to comfortably dismiss as pure coincidence. Few archaeological sites illustrate this deep interpretive tension more clearly than the Giza Plateau, specifically regarding the Great Sphinx. Geologists argue the deep fissures on the monument indicate prolonged heavy rainfall, placing its origins prior to the region's desertification. Conversely, conventional timelines attribute this erosion to wind and sand abrasion over millennia, pointing to the smoother, later brickwork as evidence of dynastic maintenance. The physical record is this vulnerable to time and the elements. We have to ask why ancient humanity invested such immense generational effort into building structures designed to outlast them. In a world where environmental stability can vanish in a single generation, a society's most vulnerable asset is its accumulated knowledge. This risk points to the need for redundancy, distributing vital information across oral traditions, rituals, and permanent physical structures simultaneously. Early builders embedded precise astronomical alignments directly into their megaliths. Stone circles and corridors functioned as long-term temporal and seasonal clocks, capturing equinoxes and solstices with exacting precision. As continents shifted, ice sheets melted, and coastlines vanished, the cosmos remained the only truly stable, predictable reference point for civilizations facing chaos on the ground. Anchoring these alignments to the stars created a reference system that existed outside the reach of earthly disruption. While human memory and wooden records might fail, the relationship between the stones and the sky provided an enduring map for those tasked with rebuilding. Long after their original architects vanished, these fragmented ruins maintain a profound, enduring silence across the earth. Looking at the immense scale of these shattered blocks and their deliberate, sky-facing alignments, one unresolved question lingers. What exactly has humanity been trying to remember? These overlapping mysteries, the repeating cycles of cataclysm, and the human drive to encode survival into architecture are cataloged comprehensively in the text Earth, Sky, and Stone. It leaves us to wonder just how much of our deep past remains hidden beyond the edge of our current understanding, and how many times the long vigil beneath the sky has already begun again.